Alright, here's our second proof video. This is going to be specifically dealing with properties. We're going to run through about 6 or 7 properties here. And some problems you're going to see will give you a snippet of information and ask you, hey, what property is being used here? So that's where you would use these two pages of your notes to identify which properties are being used in specific situations. So we're going to start with the addition and subtraction property. Technically, you might see these guys named with addition and subtraction properties of equality. And the reason why they add that of equality is because you're used to solve equations. And when you do these, you're keeping the equation equal. So when you add or subtract the same value to each side of an equation. And how that would look with addition. If you have something like x minus 2 equals 5, you might add 2 on both sides. Technically, that's the addition property. Why? Because you're adding 2 to both sides of this equation. Subtraction would be similar. But instead of adding, you'd just be subtracting. So minus 7 both sides. And keep in mind, you're not simplifying most of the time. You're just really setting it up. So technically, you might be like, oh, hey, I can do that in my head. Cross the 7s. X equals 14 minus 7 is 7. X equals 7. I'm done. Again, you might see that, but usually the problem will just stop right there and say, hey, what property are you using here? Next two are multiplication and division properties. And here too, you might see the of equality at the end of these properties. And what these properties are is when we multiply or divide the same value to each side of an equation. So multiplication could look like this. If we got something like x over 3 equals 4, the multiplication part would be timesing both sides by 3. We want to do that to isolate our x. Or with division, we'd go 3x equals 18 and divide both sides by 3. That would be your division property or division property of equality, depending on how you want to do that. Now there's one more property that I touched on yesterday, or not yesterday, but last lesson. That's the substitution property. And the substitution property is when you substitute a value or one thing in for a different thing. Okay? Specifically like one variable in for another variable, or one number in for a variable. or could be simplifying expressions. Simplifying expressions is just a fancy way of saying solving part of a problem or making a problem more simple. So example of placing values in for a variable would be like this. If x equals 12 and 2x plus 5, then we could write 2 times 12 plus 5. What have we done? We substituted the 12 in for the x. Okay? Again, we have not solved anything here yet. We just substituted in a value for a variable. Now, simplifying expressions would be something like this. If we had 4 plus 8 times 3, and I said, hey, I'm going to simplify 8 times 3 to become 24. I have done the substitution property there because I've put an answer in for a different piece of the equation. And you guys have used these all throughout algebra. The thing that might be semi-new is just going to be associating the name with what you're doing. All right, we got about 4 more properties. And the next one's also going to seem kind of new. Or not new, I'm sorry. It's not going to seem new. We will have already used it. It's called the distributive property. It's when you multiply all of the inside terms by an outside value. I'll give you guys 2 examples of these ones. So you could have, if you had something like this, 3x plus 2, you could distribute. Remember, the word distribute means pass out. So it's like everyone's got to, get that outside term. So distributive property would look like this, 3x plus 6. So you actually do multiply and get a little answer when you use distributive property. You could also have a trickier situation, which we're going to be talking about not tomorrow, in a couple class periods. If you have like they call it a monomial out front, or a variable out front. One, I'm going to go with 2x minus 1. Well, same process, but now you're going to have to remember how to multiply these guys. Easiest way that I remember it, I go number times numbers, variables times variables. So in my brain, I split out, 4 times 2, that's 8. And then I do my variables, x times x, that's just x squared. Then we go 4x times a minus 1, keep the sign, bam, there you go. Now, the next 3 properties you're going to see in questions where it will show you a piece of information and say what property is being used here. The reflexive property is our first one. And with our reflexive property, don't get confused by it. It just says any value equals itself. So it's one of these things where it's like, well, yeah, we know 12 equals 12, yeah. Well, with math, they kind of want to have properties for everything. So we say, if you see like x equals x, or AB equals AB. If one side is exactly the same as the other side, then you can say, that's reflexive property. Or if we're working with lines, maybe xy is equal to xy. Okay. 2 more to go, almost there. You can always pause the video and give yourself a stretch break if you want. I know this stuff's real exciting though, so I understand if you just want to keep going. Symmetric property. Symmetric property has a word you've probably used before, or at least heard of, called symmetry. Symmetry, think like mirror image. And what the symmetric property does, it's the switch of an equation or a value. Examples would be, you can see it a couple ways though. You could say AB equals BA. What flipped here? The order of the letters. A and B flip-flopped. You can go 3 plus 2 equals 2 plus 3. Again, we're flipping around there. You could also flip, what's it called? Like total things. Or flip around the equation. Like if angle 1 equals angle 2, that's a 2. Then angle 2 equals angle 1. So here we flip-flop the whole equation around. The left side with the right side, we flipped it around. You can also go like this. If 3 plus 2 equals 5, then 5 equals 3 plus 2. See how we do that? Again, we're just flipping around those two pieces. And last but not least, this is the transitive property. And what this guy says is if A equals B and B equals C, then A equals C. And what you're doing is you're basically making a link right here and connecting those two pieces so that you can connect the ends. And honestly, we do this all the time. You guys do this with critical thinking and whatnot. So, example, if x equals 3y and 3y equals 12, then x equals 12. And here you're going to notice right here you have a special link. You have the exact same thing in the middle so you can connect the ends. You must have a special link. The middles must be the same to use transitive property. Transitive property is really like a unique substitution property situation. So anyway. Well, there you go. You got all your properties there. We're going to look at a few examples next. Again, nice job. Stand up. Give yourself a break. That's a lot of writing. And good news, that's easily going to be the most writing you're going to do this month.